Now I'll share the screen. There we go. Can everyone see where we left off? On suspension operating principles. Sorry if I keep coughing. Water here. One of the downsides from working from home for me, I think, is there's too many cigarette breaks too easily. So having to leave work to smoke is probably a good thing for me. Anyhow, the operating principles of suspension. So the 4 different types of suspension, we talked about 3. The one we didn't talk about yet is a solid mount suspension. Does anyone work with off-road machinery? I'm hoping there's at least 1 or 2 of you who work with off-road equipment. So typically you'll have what's called a solid mount suspension. So there won't be any particular energy absorbing device, as in there won't be a leaf spring, there won't be an express rubber cushion, and there won't be air springs. What you might see is rubber bushings. They wouldn't be rubber cushions, though. And so a little bit different suspension. Something common for everyone to think about is something we talked about a little bit in section 101 is forklifts. Forklifts have a solid mount suspension. That's because you don't want them to move around so much. So all of the shock absorption happens in the tires, different types of tires you can get with them. Indoor and outdoor ones. So we're going to talk about how solid mount works, as well as leaf springs, rubber cushions, and air springs. And those are the 3 most common types you'll see, and as well as the solid mount. So units that have solid mount suspension will typically have a high center of gravity, operate in an off-road environment or rugged terrain, and require long suspension travel. So solid mount suspension, yet again, it might be on when you're attaching the where the tracks attach for bulldozer, that they're on with essentially bearings, and or so they can move quite freely based on the position of the unit, right? It depends on application. For us, for on-road, anything that's going to have a solid mount suspension is either going to be really, really heavy and really awkward, so they don't want it to move much, as in a forklift, or off-road environments, so really rugged terrain or really rough stuff, and it would beat the heck out of even rubber blocks. So rubber blocks are the next go-to for what is what's used. So you can see here is a solid mount suspension. This is a tractor solid mount suspension. So you can see you still have the center bushing here. This is where you're going to get your pivoting action. So this is where you get your suspension travel. Okay. They don't want any rubber blocks or springs or any other types of devices in here to limit this travel. This can move freely up and down that way, and also this one will go the opposite direction. Okay. So this is our solid mount suspension. What makes it different from any of the other ones, you'll see this whole walking beam assembly underneath here with these equalizer beams and these beams here. This is going to be the same in all of these pictures. What makes it different is this saddle assembly here. That's where you would typically have your energy absorbing device. So what I was mentioning there, just a little bit, solid mount suspension with the saddle assembly here. So that is that there. What it's going to have is a long suspension travel. The way it does that is through this beam and the pivot points here and the pivots here as well. Okay, that's how it attains this. Now, they call it an equalizer beam, and because it equalizes the amount of travel. So what they're saying here is if this front portion, they don't mention it, the way that if this was going over a pivot, if this side was moving down 15 centimeters, and so then in order to ride up this bump here. This drive axle had to lift 15 centimeters. The equalizer beam splits the difference. Sorry, I just got an email from help desk. That's why I was distracted for a second. The equalizer beam will split the difference, and the frame will only end up having to lift that 7.5 or half of what this is. Okay.
They do have these on 45 tons on the steer axles, actually, these equalizers.
Oh yeah, on twin steers.
Yeah, you bet.
Would it have a leaf spring right here then as well?
2 leaf springs. So those where those rear axle housings are, there'd be connectors or whatever. Yeah, there'd be the leaf springs, one on that side, one on that side, and it's kind of hard to explain, but one's on the bottom, one's on the top, and they act with the springs.
Gotcha. Bed trucks are their own beast. They're their own unique little world. So they have their advantages and disadvantages for working on them from our perspective. So we got twin steers, and they even make tri steers now. So depending on how the where it's designed to go, what it's designed to do, yeah, it'll absolutely on the steer axle could have something like that. And it might have drive axles that look like this too, right? It can be a twin steer, quad drive, like all kinds of crazy things can happen, right? So,
Savannah Wells, sorry.
No, go ahead, please.
Savannah Well Servicing has some dog houses with 3 steers.
Yeah, it's crazy. It's crazy. It can become a lot, and I mean, just trying to carry more weight is all they're trying to do, right? So leaf springs, they were one of the first suspension used. They're pretty basic. They're found on all kinds of applications: trucks, trailers, steering axles, drive axles, singles, tandems, tridems, all different kinds of trailers. On bed trucks, they're all over the place. You can find leaf springs. So the most common type is called a semi-elliptical because of its curved design. In order to make spring steel, it is heat treated specifically to have a spring characteristic. So if you heat a spring, you will lose its springiness, which essentially means then it will bend and it will just remain permanently deformed. So for us in heavy equipment, springs look a little bit different than they do in your pickup truck. Well, they look the same, just a lot bigger. So a lot thicker material in each leaf, and typically a lot more leaves in each pack, okay? Something that is quite common for in our industry to see is a leaf spring suspension like this, okay? So similar equalizer beams, and here you have that energy absorbing leaf spring assembly there. And we'll get a better picture of that too in the next ILM. So 2 different types of leaf springs that we have: constant rate leaf spring and a progressive rate leaf spring. So a constant rate leaf spring, no matter the weight you put on it, it will deflect or compress the same amount. So if a constant rate leaf spring, a load of 300 kilograms, deflects or compresses, you can see how it's getting closer together here, right? The arrows there are pointing up and the frame is coming down, deflects 3 centimeters. So if I double this, if it's constant, this should double as well. And we test it and it does. Okay, so that's a constant. Sorry?
That was me yelling at my kids again.
Oh.
Sorry.
Mute yourself. There you go. You might even be able to hear things in the background too. There's neighborhood noises around me as well. So, so a progressive leaf spring is the opposite of this. What a progressive leaf spring means is that it's going to change its rate of deflection based on its contact points. So how it does that is by adjusting the effective length of the spring, okay? So here, our leaf spring is going to be nice and long. So our contact points are out far and wide from each other. So it'll be really nice and springy at this point. Really long, right? If you get a long piece of steel, it's really, really springy, all right? As it compresses or deflects, it's going to start getting longer. These portions of the leaf spring here and here can slide. They can slide on these cam brackets. As they slide on the cam brackets, you're changing the point of contact from here now to here, from here now to here. So you've shortened the length of the spring. So it gets stiffer. The higher you load these, the less deflection they get. Okay. An auxiliary spring, they're just designed to increase the load capacity of the suspension without decreasing ride quality. So where you start loading the vehicle up higher, 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 the auxiliary springs make contact, and now they're going to help support the load as well and help maintain springiness. Because as I keep loading this spring up, it gets stiffer and stiffer and stiffer. Eventually, it just becomes a solid piece of steel with no spring. This will help bring some suspension travel back. Okay? You can see this one's fully extended. This one is as well. Where do we put leaf springs? Most commonly in a tractor, your everyday highway tractor. Pull it off of the dealership lot. It's going to be in the steer axles. Okay, that's still all over the place. You use this. Your front is going to be hooked up with one pivot point. Okay, you'll have one here. And in the back, you'll have two. So there'll be this upper pivot point, and then the lower one will be in the eye of the spring. They'll be connected to between the two with this shackle here. Why would we need two pivot points on the rear of this spring?
Forward and backwards.
Almost. So forward and backwards. Why is something moving forward and backwards? Especially now that I take a look at this picture here.
Because it gets shorter and longer.
Yeah, it sure does. Just like a progressive rate spring, a constant rate spring is going to change the length as well. The thing that doesn't change on a constant rate spring is the point of contact, because we have a solid pivot there, and then the one pivot point there, it moves the shackle back. So the pivot point remains the same, thus the effective length remains the same on the spring. Okay, so that shackle is to accommodate for that change of length. That's how we're going to attain that. Just another typical design. Instead of a shackle, this one has a rubber block in here. This rubber block allows the spring to expand and contract lengthwise as well. In between it, it also holds it like a bushing. So the rubber acts as a bushing, just like in the front here, you would have a bushing with a steel pin in it, most likely. Uh-oh, I'm clicking too much. There we go. Zoom out. There we are. All right. So they talk here. This is the good paragraph about shock absorbers. So the stability and control is important. Springs are prone to oscillation. Okay, this word is important here, oscillation. It means they bounce several times after they're compressed and released, just about like what I was talking about with that door stopper spring. it'll go back and forth a lot. So the picture 31, this one here, uses this shock absorber to control the oscillation of the spring, okay? So the spring is what's doing the energy absorption. The shock absorber controls the oscillation of the spring. Another place where you might see leaf suspensions, but not so commonly anymore, is in the drive axles. Here's a picture of what something like that might look like for a single and for a tandem, okay? Anytime you'd see a tandem, and this is very typical of a trailer, you're gonna see this small assembly here, the equalizer beam. So they act the same function as an equalizer beam in the other instance, they just have springs working between them, okay? And then a different type of equalizer beam single spring suspension. So these ones have an equalizer beam and a spring on each axle. This one has one large spring and then an equalizer beam between each axle, okay? Now, this picture is very, very small. Typically, this spring assembly here that my cursor is on would be 14 to 16 inches thick. So that's this thickness here. It could have 16 leaves and each of them are about an inch thick. So that's a very big leaf spring that's in there. Has anyone seen that kind of assembly?
Garbage trucks.
Mm-hmm. Yeah, I'd have to look at the garbage truck. It was just garbage day today and I didn't look, but next time I'll have to stop them and say, let me take a picture of your suspension. But yeah, I'd imagine a garbage truck would be a good place to have that. And they probably wouldn't even have the biggest ones that I've seen yet. Like I've seen this on bed trucks and they are very, very, very large. So
For that garbage truck, a big part of that is it's to prevent that lateral movement, because they get a lot of their weight, the center of gravity is really, really high on a dump truck, like a garbage truck. And so they have to have that stiff walking beam suspension. If they just had regular bags, they'd be breaking shit all the time.
Yeah, we are going to talk about airbags, and that is one of the big downsides of airbags is they tend to have a lot of lateral instability because it's just an airbag, right? That we've all gotten on, hopefully we've probably experienced or seen on TV what it's like to get on a water mattress, right? Just wavy, it's just a bag of fluid. That's what an airbag essentially is too. So it has a hard time with lateral stability. First, we'll talk about rubber blocks. So the rubber cushion type suspension, they use the elastic characteristics of these rubber blocks. So if you're starting to notice, so far we've gone from this same equalizer beam suspension having solid saddle up here to having leaf springs. Now we have rubber blocks. Excuse me. Are these where the rubber blocks are located on your units that are out there?
Yeah, something like that. They're actually it's one pad and it looks like an airbag almost, but it's right at the top and it's oval, but it's huge.
Okay.
Or not oval, sorry, round.
It's almost up here or like right up here kind of thing.
Yeah.
And it has a big steel hat on it. It looks like it's wearing.
You bet. Yeah, it looks just like that. Yeah.
Yeah. Okay. Yeah, just a different kind. There's another kind I've seen where instead of being flat like this, it's actually these pieces are angled down like this. And then you'd have your blocks here. And there's an opposite piece that would sit up here and then your frame.
And we have one bed truck like that as well.
Yeah, there's a few different designs of this. So all different kinds, depending on application. I've seen lots of heavy stuff. That's what I'm used to. So different types of this, different variations. One benefit of these is they're actually fairly easy to maintain and change. If you, they don't break often, which is why they're easy to maintain, And if they do, these rubber load cushions are usually really easy to change. They're one of the easier ones. There's very few connector points. So your springs typically have pins and bushings that become seized, and you have to push them out or drive them in, and that's a whole other process. Rubber bushings, if we've done any suspension work, you're pushing those out with presses, or you're burning them out and then you're trying to hammer them in or press them in, hopefully, if you have the right tools. These rubber blocks, and then airbags also, they'll have air lines, and you can blow them up, and sometimes they don't fit properly. These rubber load cushions, if you have the ability to lift the weight off of the suspension, it's usually just a few fasteners. In this instance, it's one large fastener, but other than that, it's pretty easy to change these from my experience. They're one of the easier suspensions. So while the rubber block is working, it is actually compressing like this. This is what the manufacturer is saying. So when there's no load on it, it's fully expanded. There's no energy stored inside of there. There's a portion in the center of the block, and I wish I had the block at home here to show you, where you could see the center portion is shorter than these outsides, okay? Once you start loading it up, putting all that weight in there, gravel in there, sand in there, whatever it may be, these start compressing and squishing out and expanding, and eventually this center one will also start supporting weight, okay? The other important component of these is this vertical drive pin, okay? This holds you in lateral stability as well, and there is a bushing in here. So it does allow some slight movement, but not out of control. It maintains its positioning. Okay, so a vertical drive pin allows the saddle up and down as the load cushion to flex and maintains the alignment of the saddles with the frame. So as this is moving up and down, it's not allowed to shift side to side. That's what this vertical drive pin is doing. Air suspensions. Superior ride characteristics as well of the air suspension. They reduce driver fatigue as well as damage to cargo and the vehicle. Now, that is expressly a problem of long haul cargo carriers. If you're hauling toys to Toys R Us from Ontario to Alberta, air ride is what you're going to want on your trailer, and it's what you're going to want on your tractor. Okay, and I mean, the largest portion of trucking, if we look globally, is that. That is what a really huge portion of it is product delivery. So moving things from point A to point B, long distances. A lot of times you're worried about the condition of the vehicle or of the cargo, and you need to have good driver reduce fatigue because they're driving for the maximum amount of hours and a maximum amount of kilometers. So for its place, air ride is the best. It's great. That being said, for off-road, rubber cushion is the best. In some instances, if you're looking for inexpensive, durable, and overall good, leaf spring is the best. It's the best for whatever your specific needs are, right? It's always going to be what it comes down to. So air suspensions don't give that lateral stability, okay? So for that reason, air suspension is not normally used in a vehicle that has a high center of gravity or operates in off-road environments. Now, do you see tractors out there on all kinds of crazy places there? It has the highway fenders and airbags, and you know, it looks like it should just be on paved road. Absolutely, these things do happen. Is that guy the guy who's probably breaking down and getting stuck in the mud a lot? Most likely. Maybe his vehicle wasn't quite spec'd properly to be out where it is. Do you guys encounter that out there?
I hauled fuel for about 4 years, and all of ours got air suspension on them.
Mm-hmm.
Most of our trucks that go to and from like a bunch of the mills all over the place, they end up driving through lots of mud and everything.
And they probably all have air ride on them though.
Yep.
Oh yeah.
So does all our units.
For tractors, it's almost the standard now. You have to try pretty hard or look at something very specific to have a different kind of suspension. Air Ride has come a long way, and it's not necessarily that they've made airbags any different. It's all of the other components that go along with it to maintain stability. The one thing you won't see is trailers with certain suspensions in certain applications. They come pretty specific, but yet again, airbags are becoming the most popular almost all across the board. So they're working with it, and it's because they do like the characteristics of airbags. They are nice, and the one huge advantage to airbags. Anybody know what it is off the hop, I guess, before I keep going?
Smoother ride.
Smoother ride, but what else? I skipped over it here. It's actually
You can raise and lower the height.
oh, okay. That's probably actually not an advantage. That's a disadvantage. But what Air Ride is designed for, and whoever said that too, it depends on the application, because there are applications where you do need to adjust height. And you're right, with tractors, you should dump your airbags before you pin up. That's supposed to be standard practice. For trailers and specifically, it's no matter how much load you put on your airbags, you're going to maintain constant height. Okay, that's the big advantage of airbags right here. So as you offer that load to the vehicle, it maintains the same height because it just can put more air pressure in airbags. So that's why everyone likes airbags. No other suspension can do that. You can't lift the leaf spring up. You can't lift the rubber cushion up. A solid suspension doesn't deflect, so you can't change it. But the airbags maintain constant ride height. So, as opposed to a solid mount suspension, which would maintain constant ride height at the expense of comfort. There was no comfort in there. If you've ever driven something like a wheel loader across town or on public roads before, where it's quite bumpy, you'll know what a solid suspension is like. It's really, really jarring. So that being said, though, air suspension does probably require the most components out of any of them. It has the most stuff in there. Not only are you going to have air springs and almost always shock absorbers, and this picture here is a good picture of what gas-filled shocks look like. So I was picking out Peterbilt's before, but a lot of times this shock absorber might be gas charged. And so as soon as you take this bottom or top mount out, it would want to expand on you. Excuse me. Now, the other thing, this main support member in here is actually a spring as well. Some companies actually call it a spring. In this picture, they aren't. They're calling it the main support member, but this piece is designed as a spring in some applications that could look just like this. Okay, and we still have our transverse and longitudinal torque rods, okay, serving the same functions. This spring in this instance wouldn't actually be solid inside of any pivots, okay? This spring would just be able to ride freely and would come out as a hook on the front. And what limits its travel is the torque rods. So before I go any deeper into the air system, because it's the most complicated one, has anyone got any questions so far?
Did you ever mess around with that New Way 8-bag system?
With a New Way 8-bag system, like on Kenworths?
Yeah.
Yep. Oh yeah. Unfortunately, way too much.
Yeah, that's a thing of the past now, I think, too. Eh?
Well, I bet you could probably buy a brand new one with it. I don't know for sure. I mean, it's been a few years since I've been out of it, but they were selling brand new ones when I was still pulling wrenches like 3 years ago, 4 years ago. That's the one, and it has those solid pipes that go up, drilled holes in the web, and goes to really big fittings on the top of the airbags, right? And there's 2 airbags per wheel end, essentially.
Yeah. We had
Ferris
them on.
has a bunch. Go ahead. Sorry.
Go ahead.
Ferris has a bunch of Peterbilts. They're like that. Just the day cab ones that they pull their N2 trailers with. They're all 8-bag trucks.
Yeah, it must be something Packard did then if Peterbilt has it. So, right, Kenworth and Peterbilt are the same company. They're both owned by Packard. So, there were some advantages to that system as well, and in their application, they might have been good. And I'll get to that once we talk about the ride height valve as well. So all the additional components you're going to need to make your system work now. You're going to have the air springs. So to make your air springs work, which with bags, you're going to need an air reservoir, pressure protection valve, ride height control valve, and a 2-way dump valve. So that's how we can dump that suspension out at the end of the day or when we're parking or hooking up or whatnot. We're fortunate because we have air systems on our unit. Air is how we get our braking still, so we have regulations about air. We'll talk about the air systems, how we get that air later on in the next few weeks as well. Right now, we just need to make sure we know that the air going to the suspension system comes from a pressure protection valve. Now, what this pressure protection valve says and does and only allows, and it doesn't say it, it does it by mechanical means, is at 70 PSI or less, it's going to close. It's closed off. So that's why in the morning when you start up a tractor and it's airing up, and then all of a sudden you feel all the airbags lifting up at the same time, the ones in the cab and the ones in the suspension, it's because you just went over the pressure protection valve pressures, okay? The idea behind that is if you get a large leak in your suspension and you can't keep up enough air pressure in your braking system, so your air supply system can't keep up to the leak in your suspension, can't maintain 70 PSI, it'll close that pressure protection valve and you will have air in your braking system, at least 70 PSI. Sometimes they're set differently, but we'll talk about the exact number that's regulated. So this ride height control valve and this dump valve a lot of times can be integrated into the same component nowadays, and this 2-way valve is going to be what's inside of your cab, okay? So the air springs, this is the airbag itself. How they look inside, okay? If you probably at this point in your journeys along mechanicking have seen the inside of an airbag, probably not because you wanted to, but because you had to cut the bag itself in order to start getting it off, right? Inside, there's a lot of times this rubber bumper. This is what this plate and this bumper will make contact, and that will be your suspension stop in that direction all the way down, okay? And then just a different design of airbag that has 2 bladders, and the manufacturers determine or name these things differently based on the amount of studs, the amount of ports and fittings, the way the base is, the way these lobes are. So if it's a rolling lobe or a double convoluted style, there are hundreds of types of different airbags, okay? For those of you who already have answered that one question, if you're looking for what kind of airbag you need for a specific task or a specific application, the manufacturer, they're the ones who are going to be able to tell you that. And we will go into all of this in the air brake section, the air supply system. Pressure protection valve, so like I said, closes at a certain pressure or opens at a certain pressure. So above 70 psi it is open, allows air to go to the ride height control valve. The ride height control valve, this is going to be what tells the air suspension where you're sitting. So you have one portion of the ride height control on the frame. It has an arm here, and this is attached to the axles. So the axles move up and down, right? As we're loading up the vehicle, the axles are going to want to do what? Move up this way, right? We're loading, frame is coming down. They're closing this way. The axles aren't moving up. Of course they're not. They're not floating in the air. The frame is moving down, okay? Frame's moving down as we're loading it up. So what's happening, this rod that's attached right here is going to be moving up, and the lever is going to be moving then. That shuttle is a tiny little air valve inside of here, which will allow air to now fill the airbags. Okay, so through the valving here, through all those, it's going to fill the bags, lift everything back up, lift the frame back up until it's even here again. I know there's a lot of scribbling on here, but does this make sense for everyone? Hopefully.
Yep.
Okay, good.
I work with systems like this all the time, so yeah.
Okay, good, good. So for some of you, this is what you see every day. And I don't know for sure, but I'd be willing to put a little money on that there's some of you who've never seen this. And it just depends where you work. So I would imagine. But this is very common. So if you're working with tractor trailers, I bet you've seen this. Now, a couple other things you might see. So this is just a typical, well, this could be a tandem drive, okay? You'd have an axle, drive axle here, they're connected to pivot points like this, something like this, right? Okay. The 8-bag system, the way it works is it would have the arm goes forward, you have a drive axle with a wheel, and then here you would have another airbag attaching to the frame, just like this one. And then on the opposite side, you'd have the same thing, okay? So essentially on each side, you'd end up with 4 airbags, and that's where you get the 8-bag system, okay, on a tandem. This is what we're all talking about, just so if anybody hasn't ever seen it or heard about it. Now, something they do on that system, I've seen especially, and sometimes on systems like this, is they'll put 2 ride height control valves in. Anyone think of why would I want 2 ride height control valves?
Control each bag differently, like front and back bags.
Very good and very close.
To maintain driveline angle.
Excellent answer. That's why overall we want to do this with airbags.
It would be side to side, right? One valve for each side.
Yes, yes, yes. So I haven't seen, and not to say it doesn't exist, I haven't seen a ride height control valve on the back axle and then have one here that would be on the front axle. What I do see a lot, and especially on that 8-bag system, is I'll see one on this side on the back, and then I'd see one here on this side on the back. And what they're doing, or what the idea behind this is I've seen it too on gravel trucks or things that have the potential to be loaded unevenly. If I'm loading this side of the vehicle up here, and let's say this is just a 1-bag or 1 ride height system, okay? So just however it is, the guy with the scoop, the person driving the auger, whatever, however the reason is, I am only loading from the one side into my container. What's going to happen with that vehicle?
It's going to start to lean.
It's going to start to lean. Well, so that means it's going to go down on this side. The frame on the other side is going to go up. Now, the airbag here is going to start going like this, and it sees it's getting closer together, so it's going to fill this side. You're going to have uneven suspension filling, and it's not going to be able, this side's going to be filled with the same amount of pressure as this side. But because this side on the right is heavier, this side is going to start lifting even higher and higher and higher. And you could have a potential problem.
That's how with one bottle jack, I can trick a low bed trailer into lifting 6 tires off the ground on one side. I just push up on the frame and it forces the passenger side down, and it just airs the whole trailer up and stuffs the wheels up in the air.
Yeah, yep, exactly. Yeah, that sounds exactly right. You can do that. So now you can see with that, the opposite would happen if you were loading the side without the leveling valve, okay? It would start pulling this side apart. So the leveling valve or the ride height control valve here would think it is too high. So it would start dumping air. Meanwhile, this side here is getting loaded up. It starts dumping air, so it sinks even lower. This side's still gonna be going higher and higher and higher because it's dumping air as it's rolling, and it's just gonna be a bad thing. So what they did is they put one on each side that controls the side. So then this one would control these two, and this side would control these two. So if they started loading up this side, this bag pressure and this bag pressure can start getting higher pressure because there's more weight on this side, but it would maintain the same level. Make a sense?
Yep.
Perfect. And if you don't get those plumbed in properly, they do really wonky things too. Just a different picture, a different way that the ride height control might be attached, how it might be set up. So this one specifically here, with this linkage, it's rubber, and you can adjust the length by adjusting the length of these. Okay, that's how you can adjust the ride height. Now, one of you said one of the advantages is adjustable ride height. It is if it's designed for that. Because if you start playing with the ride height and it's not designed for that, then you're going to start affecting driveline angles. And whoever said that, you're exactly right. That's actually a 4th year thing where we start talking about drive shafts and driveline angles. But yeah, you'll absolutely throw off your driveline angles. You'll also change your suspension, the function of your not the function of your suspension, the reaction of your suspension. If you start changing that height, okay, you'll start bringing things too close to the limits, or you might bring them out of a place where they should be operating in perfect alignment, and so you can experience instability or premature tire wear, any one of those faults. So we should always make sure we put the correct length back. You can just see here they're showing how as the ride height has decreased, so we've gone over a bump, this is angled up, and that will open the valve in here. Okay, so it's gone from this position to this one. It'll open the valve, allow air to go to the air springs, lift them back up. Now we've gone too high, So the ride height has increased. We're taking all of the weight off of the vehicle now. So that same air pressure expands the bags even farther. And now it lifts it into the exhaust position. The exhaust port will open, air from the air springs comes out and will drop back down to the proper ride height.
So if the arm breaks off or if the nut came off and it fell off, it would go down and sit on the bump stops instead of overfilling the bags?
So if this fell off and this arm fell all the way straight down, is that this arm right here? So this nut fell off and this arm, instead of being attached there, it fell off and it was dangling down there.
I think that's what he meant, yeah.
Yeah, then it should be exhausting constantly and it'll never lift up. So if that's what you're saying, that makes sense to me.
That's when you get your bungee cord and wrap it around the frame. You go back.
Yeah, there's a couple other cautions we'll talk about these as well. They can be dangerous, and I've seen some dangerous situations happen with airbags and the ride height control valve, and that rod as well. Just like what we're talking about too. So two-way control on the dump valves, they're in the cab, so you can hit a button and dump out the suspension. A lot of times in a trailer, you'll have one in a jockey box or a little control box somewhere, and that's how you'll be able to dump the suspension, okay? And I think, oh, almost. Cab air suspension, exactly the same as frame suspension, it's just on the cab. You're gonna have shock absorbers if you've ever felt what broken shocks on a cab are like, you know what that spring oscillation is like. This is a good one. It'll just rock and rock. It's like you're on a boat in the ocean, essentially, is what it's like. It'll just keep rocking back and forth. These airbags, they work the same way air springs. They're just smaller, very little, about this round, okay? They're very small. They can be easy to change. They can also be very difficult. We'll talk about those as well a bit. Perfect. So what we'll do now, everyone do the self-test, please. This is a really good one. Do all the questions. All the self-tests now start becoming really, really good, okay? We'll talk about it and we'll go through every question. I'm hoping that all of you have seen the importance in doing the self-tests, and I'm going to just take you on your honor today that you're going to do the self-test, okay? So take some time now and start it. I'm gonna go for a break and we'll come back at 2:20. Okay, and we'll see where everyone's at with this self-test then. Okay. Any questions before I mute and go away for a quick sec?